Good morning, students. Today we're going to be working on section 7.4. So let's go ahead. I'll share the screen with you. We can get busy uh, solving or learning how to do some of these things. 7.4, here we go. And go from the beginning here. Factoring. So we did factoring. We've been practicing factoring. And I will always say that X method that we have talked about a little bit, just this, is always going to be a pretty good surefire way to do it, okay? But today we're going to practice on special cases. We talked about these a little bit when we were multiplying, but I told you don't panic if you don't see them yet. And the same rule applies for when we're factoring or when we're breaking them apart. If you don't see it right off the bat, don't panic. Just go to the regular AC method and do it that way, okay? But we're going to practice a few. See if we can learn to identify special products, which is the difference of two squares, and perfect square trinomials. So we're going to learn to factor the difference of two squares. That was pretty easy to spot because difference means subtraction, so there'll be a subtraction sign in it, and there's only two parts. So it's really a binomial. Okay, it's not a trinomial. And then the second one is perfect square trinomials. That's where I have two binomials when I've completed the factoring that are exactly the same. And then we'll work a little bit on completing the square. We don't focus on that too much in this class just because we're going to focus more on that in 1050. All right, so here I have a polynomial. And if I were to factor this, I go, oh, okay, well, that's, 1 times 25 is 25, and this is a negative 10. Two factors that multiply to a negative or to a positive 25, but add up to a negative 10. That means they're both negative, and I'm going 5 and 5. And so because a is 1, I can just do this. So you can say y minus 5 and y minus 5. And we know that that really means, and remember when we were doing multiplication and I was having a fit, if you said y squared minus 25 at that point, like, no, 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 no. Well, remember, this is the form it needs. These are identical monomials or binomials, identical. And so that's important, okay? This would be a difference, not difference, but this would be a polynomial that is a square polynomial, okay? Meaning that when I'm done factoring it, it's just one factor squared. So let's look at that quickly. Okay, here is another one. So when I looked at this one, the first one, A, when I see A as 1, I pretty much know there's not a GCF. But when I have a number coefficient on A, I'm going to go, maybe there is something. And I look at that, and there is a 6 and a B present in both. So I am going to get 6B as my GCF, and left over would be A squared minus 1. Now, this right here is the difference of squares. And how do I know that? Well, difference, first of all, I see that it's subtraction. There's only two parts, this part, first term, second term. The first term is a perfect square root, and so is the last term a perfect square root. And when I see that happen, I know, oh, okay, I can do something with that. So let's watch and see. They factor out that, and now they notice they factored out the 6b, which is our GCF, and then a squared minus 1 factors into a plus 1, a minus 1. So what if I didn't really recognize that? Well, could I use that old standby x? Sure, let's watch and see how it is. We're looking at this one right here, a squared minus 1. Well, b is missing, or it's 0. So I'm going to put 0 for b. And the factors that multiply to a negative 1. Well, there's only one set. It's a negative 1 times 1. And since the coefficient in front of the leading term is 1, then I would just have x minus 1 and x plus 1. And that's basically what they get. In this case, they use the letter A. But you can see how I could use this x thing, this was plus 1, to solve that, and that it would work. I just have to recognize that there is no b term, so it's 0. And then a times c would have been a -1. So and I'll show you that on a few of them. So let's look at this one. First of all, what's the first question we ask ourselves? Is there a GCF? And there is in this one. It's going to be 3. And then I'm going to be left with x squared. And while I'm at it, I'm just going to arrange them in descending order. Okay? Plus 4x plus 4. So all I did is put them in descending order. And now this is my new polynomial that I'm going to factor. A is 1. That's awesome. 1 times 4 is 4. And b is 4. So I need 2 factors that multiply to 4, but also add up to 4, and that's 2 plus 2. And so I can factor those, x plus 2 and x plus 2, and bring down the 3, because I'll need that, right? Okay, and that's exactly what they do here. Now, here's what I want you to recognize. Once we got to this point right here, one of the things that you can do to see if it's a perfect square trinomial is to look at the first term. And if it's a perfect square, meaning I can take the square root of it and there's nothing, it's like either 1, 4, 9, 16, 25, 36, 49, or yeah, 49, so forth. And if the last term is also a perfect square, it's a good chance that it's going to factor just like this into this kind of form where I just have this squared. How I check for sure is I take the square root of this times the square root of that and double it. So the square root of 1x is just x, or 1x squared is just x. The square root of 4 is 2. 2 times x is 2x. Now double 2x, I get 4x. And sure enough, this is what we call a perfect square trinomial. So it's going to factor into this form a plus whatever b is in this case, squared. And that's the form that we're looking for. And we can see that it does it. But could I do it using our old-fashioned method of the x box or the x graphic? Sure. And if you're not quite sure, just go with it. Okay, so I'm going to look at this one. Notice there's no b term. That's a big hint, and it's negative. That's telling me it's most likely going to be factorable. So I'm going to look at this. What is the square root of a to the 6th? Can you think about that? That would be a to the 3rd, wouldn't it? And what is the square root of 100? It's 10. So if I were just to factor this really quick, it would just be these two parentheses. One is negative, one is positive. This binomial and this binomial. You take the square root of the first, the square root of the last, and put a minus sign, and then you do the same thing and then put a plus sign. And so we have already factored it right there. So and that's one of the things we had to ask ourselves. How do you take the square root of if I'm taking the square root, just divide the exponent by 2, and that will tell you what it factors out to be, which was a to the 3rd. Okay. If I'm taking the cubed root, I would divide by 3. And if I'm taking the 4th root, I divide by 4. All right. Let's look at this one. Okay. It is a binomial, so that maybe, but if you see a plus sign, it is not factorable in this manner. We will learn how to factor it later, but they will be imaginary numbers. Okay, and we're not there yet. We're not quite into imagination or imaginary land. We're going to get there, but we're not there yet. So we would just say not factorable. So if there's a plus and it's only 2 terms, just say not factorable. How about this one? Let's see. Well, there's a GCF. So do look for a GCF. That would be 4. And then what would be left over? So I have factored it, but can I go any further? No. So this would be its factoring right there. So you do always need to look for a GCF if you can. Okay. So always first step, find your GCF. All right, so here's our summary of procedures to follow in factoring polynomials. Look for a common monomial factor, GCF. Check the number of terms. If it's 2 terms, see if it's the difference of 2 squares. If it's the sum of two squares, it's not factorable. But if it's the difference of two squares, it most likely is factorable. And then if you're working with three terms, if it's a perfect square trinomial, you can choose uh, the rule, which is just a plus b and a minus b is how it would factor to. Okay. Nope, sorry, a plus b, or a plus b, which equals a plus b squared, or it could factor to a minus b times a minus b, which would factor to a minus b squared. Okay. So those two choices, you'll know if it's plus or minus by looking at the trinomial second term. Or you can just use our trial and method error, or you can go with our X graphic that we like to use. Okay. If there's four terms, you're going to factor by grouping. Okay. All right. So let's look at this. We're going to just complete the square. So how do I complete the square? What I do is I take the B term and I take half of it. So what's half of 20? It's 10, and then I square it. So 10 squared is 100. And now this thing actually factors to, what's the square root of y squared? Y. What's the square root of 100? 10, and it's a plus because it's a plus right here. So that's how you would complete that square. So let's look at another one. There they show you half of 20 is 10, 10 squared is 100. All right, what is half of 3? Well, we're going to keep it in fraction form. We could say 1.5, but let's just keep it in fraction form as 3 halves. Okay, then square 3 halves. What do you get if you square 3 halves? You get 9/4. So you're going to add 9/4 right here. And that factors down to be X. And what did you find when you took half of it? You found 3 halves, didn't you? So plus, because it's plus here, and 3 halves. Now both those sides of the equation are equal. And I have completed the square there. And it's always best when you're doing that to leave it in the terms of a fraction. Don't take it into decimal. Decimal will make it a little more complicated. Just keep it in terms of the fraction when you're completing the square. Okay, here we have a -5 halves. So I know right now this is going to be negative, and this is going to be a. I could just fill those in right now. What is half of 5? Well, it's 5 halves. Now 5 halves, or it's a -5 halves, right? So that's going to be there. And then what is 5 halves squared? Well, a negative squared is a positive. 5 squared is 25 over 4. So that's 25 over 4. And I have completed that square. Now, this is just the basics of learning how to complete a square, but that would be something that you would do. Okay. Here they show it. They take the 5 halves, when a -5 halves, when they square that, it becomes a positive 25/4. And then on the right-hand side is a minus 5 halves squared. This time they've already told us what this is. They say this is 100. So take the square root of 100, which is 10. And when we were going this way to this way, we were dividing by a half, right? Or cutting it in half. So when we go back this way, we need to multiply by 2. So the square root of 10 is 100, sorry, is 10. 10 multiplied by 2 is 20. And then we got the 10 here because we took the square root. That's where that's coming from. And then we have just X, and it's going to be plus. So I'm going to put plus here. Okay, so remember when we know this and we're trying to find this, we multiply by a half. When we know this and we're trying to find out the other part, we multiply by 2. So there we have it. Let's try another one. This time, we don't know this, so we're going back this way. So we're going to take the square root of 9/16. Well, the square root of 9 is 3. The square root of 16 is 4. So 3/4. And then I'm going to multiply that by 2. What's 3/4 multiplied by 2? That's 6/4, right? Or it's really 3 halves. So this is 3 halves right here. Okay. But this part, when we took that, that's here, 3/4. an x. And since it's a minus here, it's going to be a minus here. But what do I put here? Well, I take 3/4 and I times it by 2. That's going to give me 3/2. Okay. And there is our solution. One more time. Well, actually, no, pause your video. I want you to work through these, see if you can do them, and come back to me. All right. I'm looking at this one. This looks like it's the difference of squares. So that just means I have a plus here and a minus here, and the square root of x squared is x, and the square root of 16 is 4. And I am done. Same thing here on number 2. It looks like I just have the difference of perfect squares. But this time the 5 is going to go first because it appears first. And then the square root of x. And how do I get the 5 again? I took the square root of 25. You're just taking the square roots of these. This one, I see a GCF. So I factor out that 3. And now I'm looking at this. This first one is a perfect square. The last one is a perfect square. The square root of y squared is y. The square root of 1 is 1. Y times 1 is y. And if I double it, it's 2y. Oh, this is that form of y plus 1 squared. Okay, or we do the x. And we just say, okay, I've got a 1 here, a 2 here. 1 times 1 adds up to 2. And since my y is 1 at that point, I can just go y minus 1, or y plus 1, y plus 1. Okay, this one here, this looks like the difference of perfect squares. What is the square root of 10? Well, if you're not quite sure, just take 10 and divide it by 2 because we're working with exponents here. And 10 divided by 2 is 5. So the square root of y to the 10th is y to the 5th. It's going to be a plus, and what's the square root of 81? 9. And then I repeat that, but this time it's going to be minus 9 because it's the difference of squares. And finally, we're going to complete the square. What is half of 6? It's 3. So I'm going to put that here and x here. And what is 3 squared? It's 9. So now we're going to do the reverse. What is the square root of 49? It's 7. And we're going to times that by how many? By 2. So that's 14. And so we have x plus 7 squared. And that is our solutions and our answers for that. There you have it. Hope you guys have a good day and enjoy some good old-fashioned factoring. Bye-bye.